Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Okay, for this topic, okay, kita pergi kepada first topic. Okay, first order system. Okay, so first you kena tahu apa itu first order. Okay, first order, idea dia adalah S power of 1. Okay, so kunci dia adalah this one, S power of 1. Okay, and then S power of 2, kita panggil dia second order system. Okay, so hopefully you can differentiate between first order and then second order. Okay, for the first order, okay, first kita nak dapatkan dia punya respon dia macam mana. Kita nak tahu dia punya time rise, time constant, and then kita nak tahu dia punya time cycling. Okay, so let's see the figure. Okay, there are two figure here. Okay, first is a block diagram and then this one is a full plot. Okay, so kita dah nampak kat sini. Okay, kita tahu dia punya transfer function dia adalah A equal S plus A. And then, so for this system, there are no zeros. Okay, tak ada zero. Okay, but there are one pole here. Okay, so S equal minus 1. S equal minus A. Okay, so you can see. So that's why this, okay, this sign, okay, cross, okay, show that one pole, okay, minus A. Okay, so and then kita nak dapatkan dia punya graph, kita kena tahu dia punya output equation ataupun output system lah kan. So you know that transfer function, okay, GS equal CS divided by RS. Okay, so from here you can find the output for C. Okay, so C equal R multiply G. Okay, so in this system we use a unit step. Okay, so you tahu unit step adalah 1 over S. Okay, so you must remember, you must know what is the pole, what is the zero, you must know what is the input for unit step, ramp, and then last one is acceleration. Okay, so for the unit step, okay, dia punya input adalah 1 over S. Okay, so you replace 1 over S and then you replace A over S plus A. So you akan dapatlah equation ni. Okay, so to find the CT, so you need to take in the inverse transform. Okay, so you just apply partial fraction. Okay, you need to find K kan. Okay, so maksudnya kat sini nanti dia akan dapatlah macam ni kan. Okay, so equal dengan K 1 over S, okay, plus dengan K2 S plus A. Okay, using partial fraction and then you akan dapatlah this one. Okay, so CT equal 1 minus exponential minus 80. Okay, for this equation, okay, they apply both, okay. They apply for steady state response and then for natural response. Okay, so natural response is a transient response. Okay, same. Okay, so kita nak tengok macam mana dia punya graph dia. Okay, for first order response, okay, first order system, okay, dia punya response dia macam ni. Okay, so dia akan dapat satu curve. Okay, dia akan naik dengan laju. Okay, laju sampailah dia akan maintain dia punya output dia. Okay, the final value kita panggil. Okay, so for example here kita nak main dengan parameter dia macam mana kan. Okay, for example kita dapatkan T equal 1 over A. So kita replacekan T by 1 over A. So 1 over A and then A ni you cancel and then you akan dapat minus equal exponential minus 1. Okay, you tekan calculator, you akan dapatlah 0.37. Okay, so maksudnya dia akan increase, okay, sampai 0.37. Okay, and then for the system, okay, so for CT, okay, CT equal 1 minus exponential minus 80. So kita dah masukkan, kita dah replace T equal 1 over A. Okay, t equal 1 over a. This one is a constant time. Okay. So bila masukkan 0.37, you akan dapatlah 0.37. Okay. So we call 1 over a is a time constant of the response. Okay. So for equation 1, we can describe the time for minus 80 to decay to 37% of initial value. Okay, and then for the second equation, okay, this second equation, okay, the time constant is the time it takes for the step response to rise 63% of its final value. Okay, so you can see here, okay, so dia akan naik dengan lajunya sama, okay, 63%. Okay. So here you can see kita akan nampak kat sini ada TR and then kita akan ada TS. Okay, so next slide kita akan tahu what is a TS dan what is a TR. Okay. Yang ni cerita pasal time constant. Okay, so you can read by yourself. Okay. For rise time, okay, rise time happen when starting from 0.1 to 0.9 of its final value. So you can see 0.1 to 0.9. Okay. So and then dia punya equation TR equal 2.31 divided by A minus 0.11 divided by A equal 2.2 divided by A. Okay. So ini dia punya equation. Okay. TR equal 2.2 divided by A. Okay, and then for settling time, okay, settling time is defined as the time for the response to reach and stay within 2% of its final value. Okay, and then, so for 2% is about 0.98, okay. So, for the time settling, TS equal 4 over A. Okay, so you can see, okay, from 0 to 4 over A kat sini kan. Okay, ni dia punya settling time. Okay, so in my slide, there are one example. So, we want to find what is time constant, settling time, and rise time. Okay, so here I show to you how to calculate this one. Okay. Okay, so for the example, we want to find time constant. Okay, time constant. Okay. So TC equal 1 over A. Okay. So from here you can find that A equal 50. So 1 divided by 50, so you get 0.02. Okay. Settle for the time constant. Okay. Second one is a time ataupun rise time. Okay. Rise time equal T I, okay, rise time TI equal 2.2 divided by A. Okay, so 2.2 divided by 50, you can get 0.004. Okay, and then last one is a time settling atau settling time. Okay, settling time. Okay, TS equal 4 over A, and then gantikan dengan 50 equal 0.08. Okay, so hopefully you understand how you get the answer. Okay, I think that's all for first order. Okay, you just remember that the first order. Okay. Okay, this one is the first order for the step input. Okay, for the ramp input, you can see here. Okay, so you just replace 1 over s power of 2. Okay, and then using partial fraction, and then you akan dapatlah equation dia something like this. Okay, this note from Ogata. Okay, so you can refer Ogata textbook to more explanation. Okay, so after you taking Laplace, okay, Ct equal T minus capital T plus capital T exponential minus T divided by capital T. T here is a constant number ataupun kita katakan pole lah kan. Okay. So untuk this case, you want to find a error signal. Okay. So RT equal CT. Okay. Maksudnya input multiply by maksudnya apa? Input minus output. So you akan dapat this one. Okay. So and then the error signal equal dengan T. Okay. So you akan dapat graph something like this. Okay. This one is input. Okay. This one is a dia punya CT. Okay. Okay, sebab this one RT kan, RT is a 1 over S square. So, bila you inverse kan, you akan dapatlah RT equal T. So, and then you akan dapat output dia. And then dekat sini, you akan nampak ada steady state error. Okay, this one, okay, here. Okay, so, and then for this one, dia cakap, okay, the error in following the unit ramp input is equal to the T for sufficient large T. The smaller the time constant, the smaller the steady state error in following the ramp input. So, maksudnya berkadar langsung kat sini. Okay, and then this one for unit impulse. Okay, meaning that R equal 1. Okay. So, you just taking inverse Laplace and then you can get this one. Okay, Ct equal 1 over T exponential minus T divided by T. Then you akan dapat parabolik terbalik. Okay. Okay, ini adalah unit impulse response. Okay, and then last one is a summarize. Okay. Okay, so this one yang detail yang saya cerita tadi kan. Okay, unit step. Okay, this one for the ramp and then this one for unit impulse. Okay, so that's all for first order, I think. Okay, so no more note for first order. Okay, so next is a topic 2 second order. So this one I will explain in the next slide. Okay, next video. Okay, hopefully you can understand the concept of first order system. Okay. Okay, that's all. Thank you.